So we're going to talk about the next shape. Hi. For who?
I don't know. Oh, I'm a buddy.
It's for Brooklyn. Okay, as I was saying, we're going to get started on the next kind of shape. Remember when we went over on that first day, when you guys watched that video anyway, I showed you all the different conic sections, and the ellipse was the one where it's like a little bit more of an oval. And then we talked about that there's something called a hyperbola, and then there's also one called a parabola. The next one we're going to talk about today is the hyperbola. And we're going to kind of do a lot of the same things that we did with the ellipse. We're going to be able to read the graph and figure out how they have it written. What does that mean as far as like, is it major vertical or major horizontal? How we find our A and our B and our C, so that if we need to start graphing our vertices, our foci, those endpoints of the minor axis, we can do all of that. Now, these equations are going to look slightly different than they did for the ellipse. I'm just going to put up here on the board. An ellipse would look like this. You'd have like x squared over a squared plus y squared over b squared equals 1. That was like our standard form. The y and the x could switch places, like the y could be written first, but the a and the b could also switch as well. Because there's a plus sign here, it doesn't really matter how they write that. It would still be an ellipse as long as it was in this form, even if these two fractions were maybe flipped or if the a and the b got flipped. Now, a hyperbola is a little different. If you look down at these equations, do you guys see how there's a subtraction sign in between them? So in this case, we can't just flip things around however we feel. We're going to have to look at it exactly how it's written to figure out what's going to be the major and what's going to be the minor. In this case, whatever's going to be the major axis is actually going to be the one that has to be written first. So if the x comes first, that tells you that it's going to be a major horizontal. If the y comes first in my equation, then it's going to be a major vertical. So I'm going to go ahead and just write that down here. Because the x comes first, this would mean it's major horizontal. And over here, because the y comes first, this means that it would be major vertical. If you look at the bottom numbers though, or in this case, they're just letters right now, the a squared always comes first and the b squared always comes second. So the a and the b will not be switching places anymore. Instead, the x will either come first or the y will come first, depending on if they want you to do a major vertical or a major horizontal. Now with the ellipse, it was more of an oval shape. A hyperbola does not have that shape to it. They're kind of more so almost like branches. When we were doing rational expressions and we were graphing rational equations, like something that said 1 over x plus 5 or something like that, those branches were what we were graphing. Okay, so that's kind of what we're seeing here. But you can kind of see on the left side, when the x comes first, your branches are going to be opening up to the left and to the right. When the y comes first, the branches are going to be opening up and down. So that's kind of how we're going to tell the difference between our two types of hyperbolas here. The c squared is also a little bit different. So you might want to circle this or like highlight this down here or something. This piece is a little bit different of an equation. When we were dealing with an ellipse, it was always c squared was equal to a squared minus the b squared. Now when we switch to hyperbolas, we're actually adding them instead. So this almost basically resembles that Pythagorean theorem, a squared plus b squared equals c squared. So we're kind of looking at something like that again. And then there is one other new thing that we'll add. Like we'll still be able to pull our vertices from our a squared term. We'll be able to pull the endpoints of the minor from the b squared. We'll be able to find our c squared now for the focus points. But there's also going to be something called an asymptote. And if you remember when we did those rational equations, the asymptote was like a boundary line. Like it was somewhere that the graph was not allowed to cross. It kind of was like a barrier. We're going to have those for these hyperbolas as well. To figure out how you should set up your asymptote, I'm just going to write a little note here. This is all going to be based off of if x or y comes first? So if the x comes first, which is what they're showing you here on the left, if the x comes first, it's always going to be the b term over the a term. And when y comes first, it's always going to be a over the b. It's going to give us a fraction, and what we're going to use that fraction for is those dotted lines that are drawn on my graph up there. Those are going to be the linear lines that we draw from these asymptotes. So for example, if it was like 2 over 3 for my fraction, I would start at the origin and I would go up 2 and right 3. You'd graph it like a normal line, and then you would connect some of those points to get your asymptote drawn in. But they should always be kind of like going in between those branches, and those branches should never cross those asymptote lines. Like I said, they should kind of act like a barrier, and they're going to keep that graph inside of those kind of parameters there. Okay, so that's going to be the new thing that we kind of add today. I know that like they're written a little bit differently, but as far as like finding our vertices and all that, it's going to be a lot of the same. So I'm going to go ahead and turn the page here, and we're going to do an example. So we're going to start out the same way that we did with an ellipse. We're going to look at our graph and first figure out, is it major horizontal or major vertical? And then we're going to get into actually finding those points for the vertices, the focus points, and the endpoints of the minor axis. Now again, remember I said whatever comes first today is going to tell you whether it's major vertical or major horizontal. So since this one, the x comes first, this means it's going to be major horizontal. That means when I graph this, they should be opening to the left and to the right. They should be kind of opening away from each other on the x-axis. Down below, the larger of the two is still going to be your a squared. So 25 is a squared. 16 is going to be the b squared. So then they're showing you down below how they're finding a, b, and c. To find just a and b, you have to square root those numbers. So the square root of 25 is my 5. The square root of my 16 is my 4. I also didn't say this at the start, but we're going to begin like we did with the ellipse. All of these are going to be centered at the origin first, and then we'll talk about how it changes when it's not centered at the origin. So 5 would be for my x-axis points, and then 4 would be for the y-axis points. Then remember down here for the c squared, it changes a little bit. We have a plus sign instead of a minus sign today. So we're adding 25 plus 16. We get 41. And then I would square root that. Can someone take the square root of 41? Tell me what that is about. Okay, so we're going to use that also when we're going to graph. So I'm just going to graph these points right now, and then we'll talk about some of those other things. So they're telling me to do this. My vertices are at 5, 0, and negative 5, 0. So I'm going to go left 5 and right 5. Those are my vertices. And if you need to, you can put like a little V by those just to kind of keep track of what you've done. Then I don't really need to go up and down 4 just because it's not going to directly impact my hyperbolas that I'm graphing, but just know that those would be kind of in there if I needed to. But I'm going to skip graphing B right now, and I'm going to graph those focus points. Now remember on an ellipse, the focus points always came before the vertices did. A hyperbola is different. The focus points are going to come after the vertices. So we're saying that our C is 6.4. So I'm going to go on my graph here to 6.4 and graph those points. So you can kind of see how they're going beyond where my vertices were. Okay, now I need to get those asymptotes in there because I do need to graph my branches in, but I kind of need to know where those dotted lines go so I don't make my branches like too wide or too narrow. I want to make sure that they fit inside those asymptote lines. So down below, we're going over how to find the asymptotes. This is kind of the new piece. Since x comes first, I wrote on the previous page, when x comes first, that means you're going to put b over the A. So down here, since X comes first, they're showing you that they're putting B over A. My B term we said was 4. And my A term we said was 5. So this is going to be like the equation y equals 4/5 x. You don't really need to write it as an equation for like the graphing purposes. Like I really just need to see that 4/5 so that we can figure out how we're going to actually draw the asymptotes. How I like to do it is I graph 4 corners, which means I start at 0, 0, and I'm going to go up and down 4 and like any combination of left and right 5, just to kind of get an idea. So that means I could go up 4 and right 5, but I could also go up 4 and left 5 to get those 2 top corners, and then I'm going to go down and do the same thing. So I'm going to start from 0, 0. I'm going to go up 4 and right 5 and draw a point. I'm going to go up 4 and left 5 and draw a point. Now I'm going to go down 4 and right 5. And then I'm going to go down 4 and left 5. So those green dots that I have, those are my corners I'm talking about. And then what I'm going to do, I can think about my origin here, is I'm just going to connect those. Now, if you have like a straight edge of some sort, like a card or something that you can use, or I have rulers that you could use if you want to, okay? Do you have one? You can connect those dots, especially to make these asymptotes look really nice and clean. You don't have to use a straight edge, but if you're a little bit wanting to make sure that your lines go in the exact right direction, you can. I'm going to go ahead and just connect these. And I like to do them with dotted lines. They need to be straight, yeah. So it's kind of like you're making a big X there on your graph. So those are those asymptote lines. Like I said, these are your boundaries. So this allows you to know where your branches should go. Now, from the vertex, I'm going to actually draw in my branch. And I'm not going to be super technical with this, okay? I'm not looking for actual points that are going to be on this graph. I'm just going to go ahead and draw the general form of them. So from the vertex on the left and the right, they should open in between those asymptote lines. They should not cross those green dotted lines that I have on mine. That's how you graph a hyperbola. Anything major standing out that I need to clear up right now? What?
I'm still trying to
If you do want a ruler, I have a drawer over there labeled rulers. You could grab one. So I saw that.
continue.
Are you sure?
Yes. Why does yours have to be straight?
Okay, so let's do another one. This one we're going to just start from scratch. So that last one kind of gave us some guiding points here for us. This one we're going to do it all. So let's first just kind of look at the equation. We'll get to the graph in just a second. Is this going to be major vertical or major horizontal?
No, vertical.
Vertical Y?
Why?
Yeah, the Y comes first. So this tells me major vertical. That also just tells me when I go to graph my hyperbolas for this one, they should open up and they should open down. They should not be going left and right this time. Okay, what's the A squared? 36. So A is going to be 6. This means I'm going to go up and down 6 this time. B squared is 4. So my B is 2. Now, I don't really need that for my graph, but I will need that for my asymptotes. So it's good to just still write it down. Now, C squared, what do we do with the A and B squared? Add them today. So 36 plus 4 is 40. What's the square root of 40? Good, 6.3. So that's going to be my C. All of that should feel very familiar, like we did all of that stuff with the ellipse. I'm not changing any of those rules. Okay, now let's talk about the asymptotes while we're here. This time, because the Y came first, so I'm just going to say because Y is first. From the previous page, we wrote this down on those graphs. So if you don't remember, you can always look back. We're going to put the A over the B. So A is 6, B is 2. You could reduce that if you want to what? 3. I might still think of it as 3 over 1, just because I am thinking slope here. So I'm going to want to see rise and run so that I can make sure I graph those corners. Any questions on what I have written so far? Because now we're going to graph it. Okay, so I'm going to come out here to my graph. I'm going to go up and down 6. Then I'm also going to go up and down 6.3 because those are my focus points. So really, really close to those vertices this time. So this is a vertex. This is the focus point, vertex, focus point. I need to do my corners. So I'm going to go from 0, 0, 3 over 1. So I'm going to go positive for both, negative for both, 1's positive, 1's negative. I'm going to do all those combinations. So I'm going to go up 3 over 1, up 3, left 1 to the other direction, and then I'm going to go down 3, right 1, down 3, left 1. You could have also still done that, though, if you kept it as 6 over 2. So I'll just graph those points in here as well. If I had done over 6, 2, those points would be here. It really shouldn't matter, though, because they should all be on the same line. So when I go to connect those, they should all still connect. Oh, I think I didn't go far enough with this one. Should be there. So that way, when I start to graph them, you can kind of see. There's an asymptote. Here's the other one. And then you can draw in those branches. Remember, this time they open up and down. And again, they stay within those asymptote lines. So don't get too crazy with your branches. Any questions on graphing them so far? Okay, like I said, so far we're keeping it at the origin. We will eventually talk about what happens when it's not at the origin. We're going to take a break from the graphing, though. Okay, if you guys go to the next page, we're going to talk about how to write the equation. Is everyone good here? I don't want to move if I'm going too fast.
Yeah, you're fantastic.
Okay. Okay, now we're going to write equations of these hyperbolas. So they're going to give us some information about them, and then we're going to have to try to figure out how to write it. So, for example, the first situation that you might run into is they give you the vertices and they give you the focus points, and we really got to look at how they're written to know whether it was major vertical or major horizontal. So the vertices are 0, 3, and 0, negative 3. The foci are 0, 5, and 0, negative 5. Do you guys know, just by looking at these, is this major vertical or major horizontal? Why is it vertical? Yeah, the numbers are in the Y. Okay, so when there's zeros in my X's, that tells me it's major vertical. Good, so I'm just going to write that there for myself, just to kind of keep a note. Since it's major vertical, that means that the y squared term is going to have to come first in my equation down below. Because whatever comes first determines what the graph does. So that's why down here they're putting the y squared on the first fraction and the x squared goes on the second one. Now, I just need to figure out the numbers. So A is going to come from your vertices. Okay, so that's going to be the 3's. So they're saying down here A is 3, so you square it to get up to your A squared because that's going to go in your equation, and that's the 9. And that's going to go underneath the first term. So the A squared is always going to come first. So this 9 came underneath the Y. My foci are giving me the C because that's what they came from. I don't really need to worry about that for my equation. So the foci is great for me to tell that it's major vertical, but it doesn't really help me finish out my equation. I have to use that C to help me find my B. So over here, they're showing you that now that you know C squared is 25 and A squared is 9, we plug it into this equation and we work to solve for our B squared. I don't really need the B, but I do need the 16. So they did just take it one extra step, but I don't need that for my equation. I need to take that 16 and that needs to go underneath the X. And that's how we get to this answer here. So the y squared's first because of how those vertices and foci were written. And then the a squared always comes first, that's the 9. And then the b squared comes second, that's the 16. There's your equation. So this is your answer here. Okay, so let's do another one that's like this. So is this major vertical or major horizontal? Good, horizontal this time. Because those numbers are written in the x spot. That means down here for my equation, x squared needs to go first minus the y squared equals 1. So we can already get that set up just by looking at how those coordinates are written. What is my a term? The 4, because it comes from your vertices. A is always going to represent vertices. So a is 4, so a squared is 16. So that should go underneath the x squared down here. So 16, we can go ahead and just drop it in there. The foci does not give me my b, it actually gives me my c. So c is 6. So what would c squared be? 36. So let's find b squared. So remember, c squared is equal to a squared plus b squared. So I know c squared is 36. I know a squared is 16. Plus b squared. What's b squared going to be? 20? I don't need to square root it. Okay, I just need 20 to go here underneath the y. This is your equation. Questions on how to write an equation like that? Okay, so you can kind of see on the next page, we're kind of transitioning to these hyperbolas that are not centered at the origin. I'm going to stop here for today. We will pick this up when we return.